Hello, Arturo.
Yes, sir.
Hello. How are you
Hi,
doing?
how are you? Great. How about yourself?
Just fine, thank you.
Nice.
Brandon,
Yep, I'm here.
I believe you have a great project, aren't you?
I want to think so.
Yeah, hopefully.
Okay, okay. We are gonna wait a few more minutes for others to join us.
Okay, sounds good.
Okay,
Yeah, we have it ready. So whenever you're ready, we'll show it to you.
okay. Hello, Vasily. Vasily,
Yeah, I'm here.
your project is ready?
No, I'm still working on mine. I'm having an issues with the. I was gonna use a transistor, but I'm trying to use an AND gate for my motor. And once I get that working, it should be ready.
Would you please show me the circuit? The circuit
Uh,
diagram.
Yeah, let me connect my other laptop with the camera. And
Okay,
I can show you after I get that up and going.
okay. Hello, Jordan.
Hi there.
Hello, how is your project?
Benjamin, in my project is going pretty well. We've got a demo and we're excited to show you.
Okay, great. Ben May. Hello, Ben. Are you around, Ben? Ben? I think we may start. Who wants to be the first?
Artur and I can go first.
Okay, great.
So let me just share my screen and I'll go over the code. Okay, this is it. So right here, we're just defining some variables and we're including a library for my humidity and temperature sensor on board. Then we're just creating some more variables for humidity, the temperature in Fahrenheit and Celsius. This is a delay variable that we're able to change.
Would you
and then-
please tell us about the project from the beginning? What is it all about?
Yeah, I can walk you through it. So basically what we're doing, my Adafruit didn't work last time and I didn't get it to work anymore. So I ended up using my Arduino
Yeah,
to the project. So what we're doing, we put a motor, a fan, and an interrupt. And I did it backwards. So basically what we're doing is when the temperature sensor looks at a certain temperature, the fan is gonna come on. I'm replicating like an engine fan, right? So when it gets to a certain temperature, the fan is gonna come on, and then we have a button to activate the interrupt. And then once the temperature goes down to that specific, let's say we can have it at 75 already, but it goes below that, then the motor is gonna turn off and it's gonna print, okay, on or off, or the fan is off and stuff like that.
okay. Now we go through the program
Yeah,
and we
you
see
can
this
program.
feature.
Go, Brandon.
Yes, will you start from the beginning, please? Yes.
So we're just assigning variables for the DC motor. Just like speed and then the interrupt pin we use, then enable pin. This down here is for the humidity and temp sensor. We include a library and then define like a pin we're using for sense because we're using a monolithic like external temperature sensor. And then we have float variables for humidity, temperature in Celsius and Fahrenheit. And then whether the fan's on or off. And then we just begin communication with the humidity and temp sensor. We're setting our pin modes here for the DC motor, and then analog and digital right. Here we're defining the attach to the interrupt and starting serial communication with the baud rate. Then we're reading the temperature in Fahrenheit and Celsius, and then we print that to the serial monitor. And then we do a delay. And basically, if the temperature is greater than a set point, we have it set to 74 degrees Fahrenheit here. Then the fan turns on and it prints that the fan is on. Otherwise, the fan just stays off.
Yeah.
And then this is the function that runs for the interrupt.
Yep. And the library included, you made it yourself or it is with the Arduino?
It is an Arduino library. We didn't have to make it, right? Oh, I didn't think we did. Because we already had the temperature sensor, humidity sensor, so we had used the library from them. I didn't think we have to make it, right?
Okay, would you show us the motor running?
Yeah, I'll show my screen right now. Can you see the all right, so that's the setup right here. The motor's not running right now. So I have the temperature. I was playing with it earlier, so I just changed it to 85. And right now it's printing right now the temperature. And I'm using a heat gun to engage the motor. So that's my sensor. I'm using a power supply to power the L293 chip right here. And I have all the pins from the Arduino to the chip. Here's my interrupt button. That's the humidity sensor. And I have a 9-volt battery connected to it so we can power the fan. So right now it's reading 66, so I'm gonna turn on the heat gun.
Would you please show us the motor?
Yeah, it's right here, the fan. See the fan? You see it? Right when it goes over, you see it or no? So the fan is on right now, so it's 109 degrees. I can use the interrupt here to stop it. And,
No, I need to see the motor through your camera.
You don't see it?
Yeah.
You don't see it?
I can
So
see
the
it.
motor is attached to the fan.
Yeah, here's
See it
the
there.
fan, here's the motor.
Yeah, I can see the program now. I need to see on the screen the motor.
Oh, you don't see my screen?
No.
I'm showing
Professor,
you, right?
Professor, it's like on his video. It's not the share screen.
Yeah, it's like his webcam.
Oh, you don't see it? Oh, they don't see that?
You
We,
might-
we can see it.
Oh,
Yeah, we can see. I think the professor, you need to scroll over so you can see his video input.
Okay. Oh,
Yeah, you can go over and pin it too, if that makes it easier.
just don't let me scroll over. Yeah, here I can see it. Yes.
oh, okay, so that was the problem. Okay, cool. So I mean, I
Okay.
can go over again if you want me to show you again.
Will you please start showing
Yeah,
it again? Yeah.
Yeah, definitely. So so that's my Arduino right here. So I have I'm using a power supply to power the fan. Is my power supply right here. So
Yeah.
this is my temperature sensor right here, humidity temperature. Here's my interrupt button. And here's the Arduino, and I'm using the 2L93 chip right here. You can see it. And I have all the inputs from the Arduino to the button. And so right now, I don't know if you're looking at my other screen, but I have it set up at 85 degrees. So right now it dropped to 82. So here's the motor. And I put a fan on it so you can see that it's moving, well, when it moves. So right now it's off. So I'm gonna use a heat gun to apply temperature to the sensor. And then when it goes above 85 degrees, the fan is gonna come on. So I'm using the heat gun right now. So I don't know if you're looking at the other screen, but it's increasing. I'm at 82 degrees. So now my fan is on. This is over 100 degrees. So now I'm using the button to interrupt. So I'm gonna press the interrupt to stop it. So I release it and it prints motor off. And then if I just put the motor to the temperature, to the fan, to the temperature sensor, once it drops below the 85 degrees that I had it set to, then the motor is gonna shut off again. So right now, it went from 113 to 109. And it might take a few seconds, but. Getting it close to the Robin. Now it's at 95, so I have 10 degrees to go. And it's keep on printing fan on, so 93 degrees. 91, 89, 87, 86, 36 still. Come on. There you go. 84 degrees, fan is off.
Very good.
Okay.
Very simple, and it is doing all the functions that we needed. Excellent.
Yeah.
Thank you.
Yeah, included everything. Thank you.
For this project, please all, I need for the project, I need the Arduino subfolder that has your project, in addition to the PDF file. Okay?
Do you want like a zip file with the code or?
No, I need a zip file for the subdirectory where you have your project. The Arduino code.
Okay.
Yes, I need it as one file and another file that will be your PDF file, including the PDF will include a link to the video clip.
Do you still want also in a PDF file, right? Everything in there, like the code and the link, right, for the video, like we did at the previous one?
Correct.
Okay.
In addition, I need the Arduino file itself.
The Arduino file. Okay, you got it.
So you upload two things: the Arduino
Yeah,
file
yeah.
and the PDF file.
And the PDF with the code plus the link of the video. Is that correct?
Yes, correct.
All right,
Correct.
perfect. Got it. Thank you.
Thank you. Who will be next?
We can go if you'd like.
Okay, please do.
All right, let me start by sharing the screen. It's a bit of a production here, so give me 1 second. Let's move this over here. Okay, so let's just get this. So what we're doing is we are making a highly flexible motor controller and position control system.
Yeah.
This is our current setup here. If you can see our diagram, where we're controlling a bipolar stepper motor using a potentiometer, and we have both an internal temperature measurement to turn off if we heat our board up, and also a external interrupt that we will automatically stop motion once we hit that button.
Yeah.
And so the code for this is well, I wouldn't say it's straightforward. There's 230 lines of it. But would you like us to do the visual demonstration first or go over the code first?
No, go over the code first.
All right. So we have, let's see, where should I start here? We have a lot of global variables and defined statements to configure this very complicated hardware setup. And we have a few functions that handle individual processes. So as we begin here, we initialize our state variable. So for example, we find what our potentiometer position is immediately, and then we actually create a synthetic position using that to map to our motor position variable. Also, I forgot to mention that this motor position works with any stepper motor, with any number of steps per revolution, and even DC motors if it's set to 0. We'll get to that in a minute. So inside of our main loop, we find the position of the potentiometer, and then depending on where it is compared to where the motor is, we either advance the motor or we go backwards. And how that works is we have this main function here called motor command, where depending on its inputs, it can either stop the motor, run a DC motor, or it can run through a state machine, which can drive a unipolar or bipolar stepper motor with these varying inputs. State machine is handled through this non-negative modulo counter. We have individual, we have this interrupt command for stopping the motor using an external interrupt. We have an additional one for slow stopping the motor if the over temperature condition happens, and then we have a separate subroutine for measuring the temperature.
What do you mean by slow stop? Slow stop means you are disconnecting from power and let it stop by itself?
In this case, it can do a couple different things. If a DC motor is connected, then it will just it will continue going, but it'll go slower and slower and slower. In this case, if a stepper motor is connected, it will also go slower and slower and slower until it eventually stops.
Like every step will go like 1/3 slower than the next step, so it'll just kind of gradually come to a stop.
Yeah. So there's two different modes of stopping here. The emergency stop from the external interrupt immediately stops it, but the over temperature stop goes slowly.
So you are controlling the stop time?
Yeah.
Okay.
And the stop mechanism is actually different depending on what type of motor you have attached to it, but it's automatically handled. So now let's go ahead and stop that share and start turning on the video, because we have it all set up over here. It's gonna be a little difficult to show you, but we have a power supply here, everything's running off of. Just to make sure you can see this, correct, Professor?
Yeah, we can see it.
Yeah, it looks pretty good.
Okay,
It's
so
a little bit shaky, but
yeah, it's a little difficult because this is a really narrow field of view. So if we turn it on, you can see here the motor. By changing the potentiometer, it will actually track the state. So as I move it, it moves with the potentiometer. So we have position control. So as I move it, it tracks where that is. So that's pretty cool. It's a one-to-one tracking how we have set it up. We can do different ratios, but that's how it is so far. And then we have an external interrupt button here. So here, you can see that. So when I press that, it stops. And whatever it was doing, I can't move it anymore. And to reset that, we reset the board like this. And now we're back. And we can now control the position again. And so if I put my finger on the heat sensor and wait long enough for it to actually trigger it, because that could take a little while. It's also kind of cold today in here. Eventually, it will trigger a stop. But I actually think I'm physically too cold right now because I'm sick to actually trigger it because it's a really fine range. But trust me that this does work when we tested it from the video. But yeah, so here's it moving again, and then there's the stop. Yeah, there you go. So
does it have a free running mode, or do you have to control it by the potentiometer?
We could very easily make a free running mode using the potentiometer. That's just changing one line of code. For DC motors, it would be free running mode.
Yeah.
Yeah, so.
Very innovative. Thank you.
Yeah, thank you.
And it is very huge code.
Yeah, no,
230.
it's a doozy, but
Yeah,
it's cool.
Yes, it is.
took some time.
Thank you very much. Who will be next? No more groups? Is there anyone who has a problem with the project so we can discuss it together? Okay.
I'm just having an issue with my motor because I'm trying to control it with an AND gate here. Let me connect. I finally got my laptop going so I can connect here. I'll launch this meeting. 9, 3, 5, 9, 2, 6, 7. So I switched over to have an OR gate. Here we go. Oh gosh. Here, so I'm trying to control this motor here, but I was able to get the LED to work, but every time I connect the motor and send a signal in, maybe when I connect it to V out or 3.3 volts, the motor does get triggered. So I can show that here. I believe my V in is here and my ground. Hold on. V in is actually just power. So here my motor is spinning, but every time I connect it through the loop, through the OR gate, when the LED does turn on, I am not able to get my motor to turn on. And because VCC and 3.3 volts is always on, the motor is always on or always off. And I'm not sure what issue there is here.
Would the AND gate or this OR gate deliver enough current to run the motor?
Yeah, when I plug it into the LED, it's very bright. I don't have a multimeter to measure the output.
No,
when I plug,
because the LED, it takes almost no current. But for the motor to run, it needs some current. I suspect that this OR gate will be capable of giving that current.
yeah, I was able to with the AND gate, I was able to get the motor to work by itself. But when I connect just the VCC power through both AND inputs, the motor works through the gate. But if I connect my other input as A3 or A6 to have it digitally be controlled, I can't get the motor to turn on. Even it might be taking the average of both inputs. I'm not sure why. But whenever I send an A3 or A6 signal digitally, I can get the LED to work, but I can't get the motor to work through the gate. So I'm still troubleshooting.
The OR gate, before you connect it to the motor, you need to measure it with the voltmeter.
Yeah,
okay?
I don't have a voltmeter, but I was able to, when I send a signal through the OR gate just by itself, this is an OR gate currently. It does work when both inputs are 5 volts, but with one input being 5 V out at 5 volts and the other input being A3, it doesn't work.
Yeah, because as I told you, the motor needs more voltage to run. 3 is
Okay.
very low.
Yeah, so I'm still troubleshooting.
I'm surprised that it worked with 5, but anyway, but for sure 3 is very low.
Okay, I'll try to well, it does work when I just connect it to the 3.3 volt and it spins pretty quickly here. I can display it again. It's full speed here and it can probably cut something.
You are connecting to the DC power supply 3.3, correct?
Yes.
Not the output of the OR gate.
Okay, so I'll get a different OR gate and then I'll test it. I'll probably
Because you see, the OR gate has current limitation. The DC
Yeah.
power supply can deliver more current, even if it is 3.
Yeah, I was trying to find in the data sheet what the max current is, and I believe it's 20 amps. So that could be the
And
limiter.
read the motor. What is the motor requirement?
Let me get the motor. I'll have to find the data sheet for this specific motor. It's probably around 1 amp or 0.1 amp at least. So I need
how
50 times. I need a 50x step
how
up
could
in current.
how could microamp deliver power to milliamp or amp? No way.
Okay. Okay, I'll get a different gate. I think I should be able to get that tomorrow. And
Okay.
I'll test it.
What do you need from this OR gate? Why do you need it?
Well, there's whenever so when I connect the motor straight to A3, I'm not able to get enough current through there, so I need to connect it to V out or 3.3 volts. Just to activate the motor. So I'm trying to use an OR gate. There's another way I believe you can use a transistor.
Yeah, transistor can deliver more power.
Yes, but I don't have I mean, I can probably find a transistor somewhere. And try to get it to work. I don't currently have a transistor for this.
Okay.
So I'm still working on that. But I'm gonna have this motor control like a traffic stop, and it's gonna have a e-stop where it's gonna flash the LEDs and put the rail arm down. And then if it senses a car on the railroad, so whenever the motion sensor has the light below a certain value, it's gonna flash red, indicating to get off the railroad track. And I'm gonna probably put it on here, the Arduino itself with the motion sensor on here, the built-in Arduino motion sensor, I mean light sensor. So that's my
That
goal.
would be a great idea. Yes.
Right. Yeah, I just need a little bit more time to get the parts and then get it to work. I'll have a video uploaded, and then you need the PDF and the Arduino file, correct?
Okay, we have until Saturday evening. Saturday midnight is our deadline.
Okay, perfect.
Okay.
Yeah, that's enough time.
Hey, Vasily,
Okay.
if you can get that L293 chip, that will just fix all your problems about running your motor. Probably you need like an external power supply to run it. But that'll be, I mean, if you have any issues with your OR gate, that will be the best way to do it.
Okay. And the what L2?
Yeah, if you look at the actual print or the actual project 2B, it shows you that you can use an L293 Delta or D chip to run the motor.
Okay.
So if you look at it, it gives you the number. I mean, they're really cheap. They're a couple of bucks, and you can use that. And if you have like a 5-volt input from like a cell phone or something like that, or if you have like a little power supply, you can run it. It only needs 5 volts.
Okay. Yeah, I have an
And
external.
yeah, that'll be the best way to handle it, and you'll be plenty of power to run your motor.
Okay, I'll look into that. Thanks for that tip.
It is designed to work with this DC motor. It is designed for this application. So please try to get it. That's why I sent you an announcement saying try to get these parts. It could save you a lot of time.
Yeah, I got the motor. I just didn't realize I need the additional part.
No. It is stated in the announcement and stated in the project itself. Okay? Try to get it. I'm sure that it will help you a lot.
All right.
Okay?
Yeah, your second announcement with the particular models of the motor driver chip and the motor, the particular motor you had listed by model number is actually a geared stepper motor.
Yeah.
Which is not a brushed DC motor. And so that's actually caused a problem for a couple of people because they don't actually have just like a plain DC motor for the first
Oh,
part
yeah.
of the document.
Okay. What is the motor you used?
It's
We-
a geared stepper motor.
Oh, you use a stepper motor, yeah.
Yeah,
Yeah.
no, that's the one in your second announcement. It was a stepper motor. It
Yeah.
wasn't just a normal DC motor.
Okay.
So we actually don't really know how to do the first part of the document you sent because it requires a normal DC motor.
Okay. I believe you did what you did is great. Okay. I need one of them, one part that would be great. And I need to see the temperature sensor and the interrupt.
Sure.
If those
sure.
are there, that is more than enough.
Gotcha. Thank you.
Thank you. If we have no more people who want to share their experience, I wish you all the best and thank you very much for attending this class and participating. Your participation was very, very positive. And I believe, as I said, we have until Saturday evening, Saturday midnight, to wrap up any missing assignment. Okay? Thank you all, and I hope to see you soon. Bye now.
Hey,
Goodbye.
thank you.
Thank you. Bye-bye.